Hello, this is Mrs. Pullen for AP Stats, Lesson 6.03, The Basics of Constructing Confidence Intervals. And in this video, I'm going to go over how to calculate critical values based on confidence levels other than 95%. So the first one is we want to figure out the number of standard deviations 80% of the data lies from the mean. And so we're going to make our bell curve, and we're looking at the middle 80%. I'm going to just shade. So we need these critical values, and they're going to be the same values, just opposite signs. So to figure out the percentage of data that's below this critical value of negative z and above z, what we're going to do is figure out alpha. So alpha is equal to 1 minus 0.8, and that's 20%. And then it's divided evenly because the normal curve is symmetric. So we say that there's 10% in each tail. So we're going to use technology in order to get our value. So the critical value is going to be plus or minus, and we're going to do inverse norm, and we're going to enter the percentile. Remember, whatever the value is at negative z, it's just going to be the same thing, but the absolute value of it. So we're going to enter the percentile of 10. Again, we're looking at the number of standard deviations away from the mean, so it's going to be 0, 1. And we're just going to enter that into our calculator. So we're going to do menu, statistics, distributions, inverse norm, and we're just going to enter 0.10. And when we do that, we get negative 1.28. So it's plus or minus 1.28. So it's within 1.828 standard deviations above and below the mean. So next, let's go ahead and calculate the critical values for the middle 90% of the data. So again, we're going to make our bell curve, and we're going to shade. And so we're looking at the middle 90%. So our alpha, the total data that's not in the middle 90%, is going to be 10%. And we're going to divide that evenly because it's symmetric. And so we have 5% in each of our tails. So to get the critical values, and we represent them, the critical values, with an asterisk, you're going to do inverse norm, plus or minus, inverse norm, 0.05, 0, 1. So it's menu, statistics, distributions, inverse norm, and 0.05. And we hit OK. And we normally round this to negative 1.645. So that's pretty standard for this one. So if you're looking at the middle 90% of the data, that's going to lie within 1.65 standard deviations from the mean. And then finally, we're going to look at 99%. So we're looking at the middle 99%. So again, we're going to shade. So we're going to get our alpha. So that's 1 minus 0.99, which is 0.01. And then we're going to divide that in 2. And that's 0.005. And so now to get our critical value, it's going to be, actually, let's just label this. Inverse norm, 0.0050, 1. So you're going to do menu, statistics, distributions, inverse norm, 0.005. And just hit OK. And you get, this is normally written as 2.576. So 95, 80, 90, and 99 are the most common confidence levels that are used. And I want you to notice something. As our confidence level went from 80 to 90 to 99, the critical values increased. So you would end up, if your critical value increases, right? So as your confidence level went up, your critical values increased. Well, since the margin of error is the critical value times the standard error, so the margin of error increases. And what that leads to is an increase within the confidence interval. So you become more confident, you have a wider interval increases. The other thing I want to point out to you is these are the common ones, but on the exam, it's pretty standard to use other ones. So you really need to know not just how to memorize this, you do need to know how to calculate it, because sometimes they'll ask for a 98, sometimes they'll ask for a 96%. So you do need to know the process on how to calculate the critical values.